what's up guys, let's take a look at day 2 of Advent of Code. I think we're starting to see the theme because day 1 was following in the footsteps of the historian, day 2 links to an old problem, and I'm guessing the idea this year is the historian's going to take us on a tour through the greatest hits of Advent of Code. That's just my guess, we'll see how it goes. So the one this time is this radiation data from a nuclear plant, and if it's going down slowly, that's fine. It's going up slowly, that's fine. Anything else is no good. For example, unsafe if we have a big jump, unsafe if we have a big decline, or even if they're small, up and then down is no good. And the tricky one, staying the same, is also bad. I messed up earlier when I was trying this, and I had diff less than 4, and it wasn't catching the ones that stayed the same. So let's test that out. I've got basic setup, slightly better type hints compared to yesterday, but I'm still not happy. I'll still change it as we go and have a better setup each time. So the data is pretty long, but the lists are pretty short, so if we had to sort them or something, that would be okay. And then the example is what we saw. So let's test on the example, and let's see part 1 is what we just talked about. They have to be slightly increasing or slightly decreasing. And first we have to read that stuff, so I just gave it the lines, and that doesn't include mapping them onto integers and whatever. So let's say report is the name of this thing. Reports is the line, and then the label is what they use for a single thing, I believe. So it's going to be map int onto line dot split for line in lines, I think. Let's well, I was going to say let's print it, but they would just give us map objects. So let's print reports just to make sure we're on the right track and working with the right stuff. So we got a list of numbers, and that's 76421. Yeah, it's not like yesterday where we have to get the columns, so there's no zip, star, whatever. Okay. So now we need to see how many are safe, and I feel like saying the following: sum map safe reports. Like, I want to make a function to do that, and it'll be a separate little thing because I have a hunch we're going to use that in part 2 as well. So let's go def safe, and it's going to get a report which is a list of int. It's already been parsed. There's no strings anymore. It's just one line though, so it's a list of events, and it's going to return a bool because it's just yes or no. Is it safe? Okay, when we sum the bools, that's counting as 1 or 0, but we're doing it as true or false, which is the same thing in Python. There's no conversion. True already is 1, and false already is 0. So how do we see if it's safe? Well, I said a minute ago that, yeah, we could sort these, but I would still feel bad about sorting it one way, sorting it reverse, checking the difference, and then it would be like making copies, really wasteful, even though I'm sure it would be fine. So I'm going to do a slightly more efficient way to look through, and if we see that it's going up, then we start to check for that. If we see that it's going down, we check for that. And if we ever see something that breaks it, like a big jump or a change in direction, then we early return. We don't have to look through the whole thing. So how am I going to do that? I'm going to go pairwise from itertools because I want to do this guy and the next guy. I want to compare them. So pairwise from itertools is going to do that. So let's say from itertools import pairwise, and that just means the first 2 and then the next. They overlap, so you catch them all in different directions. You can see one guy as the left or the right, whatever. So let's say for AB and pairwise report. Okay. If, or let's say diff equals B minus A, and then we'll use that for multiple things, right? So we can say like, if diff is not in 1, 2, 3, return false, because 0 is bad, anything else is bad. But I don't mean just diff, I mean absolute value of diff, right? So this is like a jump up is fine if it's small, a jump down is fine if it's small, and we have to check, are we consistent? And if we start going up, we have to be up the whole way. But I think I'm going to treat that separately. So let's say like, how can we handle the direction? How can we handle like positive, negative? Well, there's a function, not in Python, but in some languages, or just the idea of this function called signum, like the sign of a number, and I'm going to use that. So I'm going to say def signum of x, meaning like the direction. Is it going up? Is it going down? Or is it 0? So I'm going to go return 1 if x greater than 0, else negative 1 if x less than 0, else 0. So this is a thing with 3 possibilities: increasing, decreasing, or 0. And so my idea is we look at the first pair. If they're increasing, we have to be that the whole way. If they're decreasing, we have to be that the whole way. If they're 0, we're done, you know? So I could do some clever thing where we like peel off the first from this pairwise iterator, but I'm just going to say use the index, whatever. Direction equals signum of report 1 minus report 0. So that's like the very first step. Is it going up or down? And that would fail if we had lists that were too short, like if there was one that just had 1 item, but they don't. They all have at least a couple. Okay, so that's fine. And then so we can say like if signum of diff is not equal to direction, or it's too big, we're done, right? And this is an early return, so it kicks out. Oh, sorry. We have this idea of efficiency where it's like, I don't feel like sorting the list upward, seeing if we equal that, sorting the list reverse, seeing if we equal that, doing this whole thing. We'll just step along. And then if not, we return true. So I just did a lot, and I wasn't really testing it. So let's test it on the example and see what happens. Hey, look at that, it was 2, and that is what they said. It was, in fact, 2 for the thing. So great, cool, fine. How about the big one? Is it going to work? Let's test this on the big boy. The data. 591, I think that's what it was. Beautiful. So we did this the whole way through. If we ever find a big of a jump in either direction, we're done, or the change in direction or staying the same, we're done. Okay. So part 2 is when it gets more complicated. They usually add some kind of extra layer to it. And in this one they say, oh, it's fine if we have 1 bad level. So like that 1 repeat is fine. We just skip it and the rest of it's okay. Or that 1 where it changed direction, well, it really only changed because of this little hiccup. Otherwise it's nicely smooth, safe, no problem. So if we were good in the old way, we're still good, and our answer's going to be a little bit higher than 591. Okay, so the good thing about this is that it's day 2. They're not making us super optimal, because I could make a separate path where it's like we check the part 1 way, and then if a list didn't hit that, then we send it off to the part 2 way. But I think we can probably just go part 2, just try a bunch of stuff, and it's going to work because the lists are relatively short and we're not having to deal with like hundreds upon hundreds upon multiplying against themselves, you know? So let's say, okay, I'm going to make part 2 is exactly the same, except for this thing, it's going to have a different function that's mapped onto them. And I'm just going to call it tolerant safe. So this will be like, hey, it's kind of like safe, except what if it's not? Okay. So def tolerant safe, and it still does all this stuff. And, you know, we could check safe first, and then if it's good, we just use that. Yeah, we'll think about it. We could just, let's try it. If safe, report, return true. So let's try that and just see if it gets the same answer, just to make sure that I'm not messing something up. But, okay. Int and none type, because this is returning nothing, which is usually good enough if you're going to use it in an if or something, but not for the sum. Okay, none is kind of like false, but not enough like false to be added. Okay, so 591. So this is exactly the same, which means in between here we put the new thing, right? The thing that's going to bring our answer up a little bit, because all the ones that qualified before still qualify. They don't need to remove one. But if they can be safe by removing one, that's fine. Okay. So then we're going to do like, well, what are we going to do? Are we going to do a thoughtful, intelligent approach where we say, hey, I'm going to march along in my safe function, and then if I find a hiccup, then I mark that down, and if I find more than one hiccup, then we're bad. Or if I just found one, then maybe I remove that one. Sure. Or we could just try everything. We could just say, hey, remove all the stuff, see if one of them works. Bada bing, bada boom. And I think we can get away with that because the lists are so short. Let's try it and see what happens. If it runs for a week, then we'll optimize. So let's say then for, oh my gosh, I'm going to do something you usually don't do, which is like the range len. Usually that's considered unPythonic, and you want to go with like an enumerate or just loop directly for, you know, num and nums or whatever. But in this case, what I'm going to do is I'm going to slice up to and after the thing, skipping each one. So I'm going to say like if safe report up to I, and then report I plus 1 onward, return true. And this would be pretty if we wrote it within any, like return any of these, but that doesn't short circuit. When you do an any, it calculates all of them. Pretty sure, yeah. Or at least if the thing inside of it is lazy, that might pay off here. But in this case, it's like, hey, we have a true. If we ever find that, hey, I removed the second one and it worked, that's enough. I don't need to keep checking to see if there might have been some other thing. In fact, if there had been some other thing, it's not true anymore. So let's see what happens there. We run it, we get 621. I think that's right, but let's test it on the example. And then it said 4. Was that what it was on the other guy? 4, and then yeah, it was in fact 621 for part 2. So I'm feeling a little guilty that I didn't optimize. I might want to try again just for fun to say like, hey, what if we didn't want to make copies and we didn't want to do the slice thing? What if we wanted to like intelligently use the safe algorithm to just note like, hey, that one is where we failed, so let's try that one instead of just trying everything. But at least we were efficient here instead of sorting the list multiple times and checking everything like that. So not bad, a little bit longer than yesterday, but still relatively, I don't want to say easy, but forgiving. Like it would have let us get away with less efficient stuff, and we'll see how long that lasts through the month. Thanks.